system model, or I just need the process value to make the machine learning model. Thank you.
We'll ask directly, or we collect the question first?
You choose ARIMA rather than other statistical forecasting method. Thank you.
Okay, last question from Novri.
My question is, what machine learning model are you using to predict the output? I think you didn't mention the model, the algorithm, and also you also didn't mention how did you specify the order of ARIMA model, and how did you verify that the model is the correct one? And also, I think when you mentioned that, when you said that the model, the prediction is not good, I think it's because the predicted input is also not good. Where you have the bad input, maybe the output will be also garbage. Okay, thank you.
Try to answer the first question. So the question is about how to create, do you need the model before you create the machine learning model? Okay, so basically machine learning is the model that I tried to create. Because when you create the model that I mean, it's actually an equation that if this input like this and then the output like that.
The system model, to make machine learning model, do I need system model? System, like if we give input to the system, we can get the output, the model. Do I need that or
no? Basically for machine learning, what you need is input and the output. By understanding the input, by you see the relation between input and then output, then you create a model. So basically you will, but of course you need a reference model. You need the reference output, so it will calculate the error between the real value and then your model, and then the error will be feedback to tune the parameter to get the best value.
is it the same, the system model, the model of the system, the system and the machine learning model, is it the same or?
That's what we try to do. We try to create the machine learning model that will have correctness level as the real model. So that's what you try to do. And when you try that, you will get when I said before, like root mean square error. You will calculate. For example, when Donald Trump he tweet something or say something, we could see that the prediction is not accurate anymore, and we can say even the model say that tomorrow it will going up, but when Trump say something yesterday, the tomorrow it will going down. Why? Because I think it's very volatile, it's fragile, because there's a lot of factors that affect the prediction. But for the, I try to choose this case, this geothermal power plant, because as I said before, that the earth crust heat is remain constant. So I think it's probably the prediction will probably accurate because the source is constant. If you try to implement it in the forex, yeah, because the source of the stability of the system is could affect by many things, like war, for example, in Hong Kong, or like Donald Trump's tweet, or some things happens in the country. Yeah, that's is it.
Maybe you can use some method, and then you can compare the movements with error.
Yeah, thank you for the input. I will try for the next research maybe. Okay, and then for the last question, what machine learning model that I use and how to order the ARIMA model, and also if the input is bad, of course the garbage in, garbage out. Okay, so the machine learning model that I use is the, if I didn't wrong, random forest. I use the random forest model to create the model, and then the ARIMA model, how to order, what do you mean is order what?
P, Q, and D.
Oh, P, N, and Q. Yeah, yeah. So for each model, the ARIMA and E, it has the, we call it the order. So like the first order, second order, third order. Especially there's a lot of, I think there's a lot of methods to determine, we call it PACF and ACF. So PACF to determine the number order of the autoregressive, and the ACF to predict the moving average. Actually, you can find it. I think I found in Medium. So this is the PACF, and also this is the ACF. So what is that? PACF is partial autocorrelation function. So by finding the correlation between observation, you could determine whether what is the best order to create the model. Okay, and then for the last question, sorry. Yeah, if the input is bad and the output is bad. Okay. Yeah, it could be happen. But before I just make a clarification about how the data is gathered by the company. So basically, if you want to create a good model, I think you need to have a real-time data. But the data that I have, the data is only gathered for 1 day. So for example, if I have 24 hours, and then this is the curve of our data, the company only took the data for example, for every 11 a.m. So the other data is removed. So by that, I could conclude that the data is actually not represent the data, the input data is actually not good, because you have 1 day data and you just only pick at one point at 11 o'clock, for example. I think if you want to create a good model, you need to have the good input also. Yeah, is it answer your question?
So I think you can use auto ARIMA library, so you don't need to specify the order of P and Q, so it will be determined automatically. Yeah.
Okay, thank you for your input. Is there any question? Yeah. Is it okay for next question?
Okay, I think we have time to one question, the last one question. Okay, please introduce yourself and ask your question.
My name is Aleph. So my question is related to the input for the model. So you choose for parameters, especially for the physics parameters, right? Yeah. And as we know that you filter first at the first time.
So for the input, sorry. Okay. Sorry, I'm looking for my presentation. Okay. So we have 5 physical variables that is used for the model. So the question is, do I use all of the parameters? No. So I only choose some parameters that I know by the from the engineer from the power plant, that they say the process variable that will affect the electricity is 3: the wellhead pressure, the flow rate, and also the temperature. So I will not use the line pressure and the throttle valve. It's based on the knowledge of the engineer. And then after that, of course, after I get the data, I do some data cleansing. Like if I found the outlier data, because sometimes if you use sensors, there's like a spike. We call it spike. So for example, if the junction between the cable is not fit properly, it will cause a spike, so the value could be infinite like that, and then I just remove all the value. Is that answer your question? Okay, thank you.
Okay, thank you, Lucas. This is the end of the first session. Let's give a big applause to Lucas as our first presenter. Okay, before we move to the next presenter, I would like to invite the guests who sit in my right, move to in the middle, because it will be more comfortable if you see the presenter from this side.